We have another integral calculus exam question. So these are exam questions I'm going over to get you ready for your exam in integral calculus. This one's about sequences and series, particularly series. So let's go through this question. I'll pause it. You can take a shot at it, see if you're ready for your exam. And then we'll go through the solution together. And then the next video will be the carousel. So you don't have to write anything down, don't worry about that. So for which values of the constant q does this sum converge? All right, let's go through the solutions then, or the options, and then I'll talk about it for a second. A, it converges only when q is less than -1, q less than or equal to -1, q greater than -1, okay, or it converges for all q. All right, now let's look at this carefully for a second. If this is just 1 over n, right, that's harmonic series, so that diverges automatically. If it's just log n over n without this exponent q here, well, that's even bigger than the harmonic, so that also diverges. So this one, for it to converge, q is definitely going to have to be a negative number. If it were positive here, then it's going to be even bigger still, right? So it has to be negative. So from this, we know it's not these two options, and it's not these options. So C, D, and E are out right away. The question is it this one or is it this one? So let's quickly take a peek. So what we can do is we can apply the integral test to this. So we said this is our function, and by the integral test, the series converges if and only if this integral converges. So we can use substitution. That's what you would do here because you have ln x, and then you have the derivative of that, which is 1 over x dx, both in the problem. So we set up our integral, we change our bounds according to our substitution, and we end up with this. Now, the whole crux of this question lies in this tip section. So make sure you understand this tip section. You can pause it, you can read it, reread it, make sure it makes sense. Let's read it together. The integral of ln 2 to infinity u to the q du is a p integral with p equal to -q. Therefore, it converges when -q is greater than 1. That is, when q is less than -1. Read and reread that. It has everything you need to fully answer this question. You can test when q is equal to -1 as well, just to be sure, and you'll see it diverges. You have to set up a limit here to answer this properly, right? Because this is an improper integral, or an integral at infinity, I should say. But yeah, the answer is A. So hopefully that helps. If you want lots of exam help, lots of free exam help, go to Pretty Good Prep. I get you ready for your exams. I used to grade these exams. Now I show you how to ace them. Hope this helped.